Good morning, students. I am Mrs. Shravanti Jagdish Vanga, working as an assistant professor in the Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. In this lecture, we are going to study indeterminate forms. The learning outcomes are: at the end of this session, student will be able to solve the problems of indeterminate forms. First, let us see the definition of indeterminate form. What are indeterminate forms? In calculus and other branches of mathematical analysis, limits involving an algebraic independent variable may often be evaluated by replacing these functions by their limits. If the expression obtained after this substitution does not give enough information to determine the original limit, it is said to be an indeterminate form. Now we'll see the types of indeterminate forms. There are 7 types of indeterminate forms. The first one is 0 by 0 form. Second one, infinity by infinity form. Third one, 0 into infinity form. Fourth one, infinity minus infinity form. Fifth one, 0 to the power infinity. Sixth one, 1 to the power infinity. Seventh one, infinity to the power 0. Hence, there are total 7 types of indeterminate forms. We will see how to solve the problems of indeterminate forms. Now, to evaluate the indeterminate form problems, we use L'Hospital rule. Let us see the statement of L'Hospital rule. L'Hospital rule is a general method for evaluating the indeterminate form 0 by 0 and infinity by infinity. This rule states that limit x tends to a f of x upon g of x is equals to limit x tends to a f dash of x upon g dash of x. If limit x tends to a f of x is equals to f of a, the limit it gives either infinity or 0 also, and limit x tends to a g of x is equals to g of a, either infinity or 0. Now whenever you are getting such case, we are going to apply this L'Hospital rule, where this f dash of x and g dash of x are the derivatives of f of x and g of x. We will see the problems of type 3, that is 0 into infinity form. Let us see the definition of this form. The limit of the form limit x tends to a f of x is equals to 0 and limit x tends to a g of x is equal to infinity are called the indeterminate forms of the type 0 into infinity. Means there is a product of two functions, f of x and g of x. After applying the limit, you are getting the first function f of x limit as 0, the second function limit as infinity. Then there is a product of 0 into infinity, which is called as an indeterminate form. How to solve this indeterminate form? If we write this f of x into g of x as f of x upon 1 upon g of x, here I have flipped this g of x as 1 upon g of x. Then the limit become of the form 0 by 0, and this can be evaluated by using L'Hospital rule. That is, g of x, when you apply the limit, you are getting infinity. Once you flip it, you are getting 1 upon g of x means 1 upon infinity. 1 upon infinity, it gives you 0. Hence, 0 into infinity form resulted into 0 by 0 form, which can be solved by using L'Hospital rule. Now, we'll see the rules to evaluate the 0 by 0 form. The step number 1 is check whether the limit is an indeterminate form or not. If it is not, then we cannot apply L'Hospital rule. Next, differentiate f of x and g of x separately. Means numerator function f of x and denominator function g of x should be differentiated separately. Next, in the next step, you have to apply the limit. After applying the limit, if g dash of a is a non-zero term, then the limit will exist and it may be finite, positive infinity or negative infinity. But if you are getting g dash of a as a zero term, then you need to follow the next rule. That is rule number 4. That is next step. What is that? In the next step, again you need to differentiate f dash of x and g dash of x separately. And we will continue this process till we get the required value. Now we'll see one example of 0 into infinity form. Now, let us see. Example number 1, evaluate limit is x tends to infinity x into sine of 2 upon x. Now, if you go through this problem, this example has the form 0 into infinity. And if you try to evaluate it directly, you are getting the indeterminate form. So, hence flipping the term which gives the limit as infinity and transform it to a 0 in the denominator will gives you the form 0 by 0. And later it can be solved by using L'Hospital rule as follows. Look, I have flipped the function x as 1 by x because if you substitute the limit x tends to infinity in x, you are getting it directly as infinity. You need to flip those function which gives the limit as infinity. Therefore, limit x tends to infinity sine of 2 by x upon 1 by x. Now, if you substitute the limit as x tends to infinity, here you are getting 2 upon infinity will be 0. Sine 0 will be 0. Here 1 by infinity will be 0. That is denominator 0. Hence, this is a 0 by 0 form. Once you get 0 by 0 form, you can apply the L'Hospital rule. Now, applying L'Hospital rule. What is L'Hospital rule? It is nothing but you need to differentiate the numerator and the denominator separately. Numerator is sine 2 by x. Now differentiating sine 2 by x with respect to x, that will be cos 2 by x. Again into derivative of 2 by x is minus 2 upon x square. Differentiation of 1 by x is minus 1 upon x square. Simplify the terms. Now this minus gets cancelled. This x square gets cancelled, students. Here you are getting limit x tends to infinity 2 into this 2 into cos of 2 by x. Now apply the limit directly. Now if you apply the limit directly, limit x tends to infinity 2 into cos of 2 by infinity will give you 0. That is 2 into cos 0. Hence you are getting cos 0 is always 1. So 2 into 1 is 2. In this way, you can evaluate any indeterminate form. by using L Hospital rule. Hence I get limit x tends to infinity x into sine 2 by x as 2. Now we'll see the next example. Evaluate limit x tends to pi by 2 sec x into tan 2x. Now here also, if you substitute the limit pi by 2 directly into the problem, you will be getting the form 0 into infinity. Sec pi by 2 will give you 0. Tan 2 into pi by 2, it gives you infinity. Now if we try to evaluate directly, you are getting the indeterminate form. Hence, flipping the term which gives you the limit as a infinity and transforming it into a 0 in the denominator, which will gives you the form 0 by 0. And now you can solve that example by using L Hospital rule. Now here I have flipped the sec x as a cos x. Now limit x tends to pi by 2 tan 2x upon cos x. Now substitute the limit pi by 2. Now here you are getting tan of 2 into pi by 2, that is 0. Cos pi by 2 is also 0. Hence this is the 0 by 0 form. Now you can apply the L Hospital rule, that is differentiating numerator and denominator separately. Numerator's derivative is 2 into sec square 2x. Denominator's derivative is minus sine x. Now simplify the terms. Simplify. After the simplification, substitute the limit. Now 2 into sec square 2 into, in place of x, write down the limit pi by 2 minus sine pi by 2. Now here you are getting 2 into sec pi square minus sine pi by 2. As we know, sec pi it is minus 1 minus sine pi by 2 is minus 1. And after the simplification, you will be getting the limit as limit x tends to pi by 2 sec x into tan 2x as minus 2. References: Engineering Mathematics by Ravish R. Singh and Mukul Bhatt. Thank you.